So again, my name is Hila Singh. I'm the Data Visualization and GIS Specialist right here at the Department of Knowledge Production at the Lead Library. And what I do is I ensure that there is the appropriate technology for you to support student learning and research and faculty and researchers so that you can accomplish whatever it is that you came here to do here at UNLV. So I start by talking a little bit about the research path and how I fit in and how I can help you out. So you know if you have questions, you have a resource right here at the library. So at the pre-research, when you need to identify analytic approach or software, you can contact me. And then as you come to write your 5-chapter either manuscript or thesis or dissertation, you kind of on your own in the writing. You have the writing center to help you out, but I'm more of like the data person, so I can help you plan for that. Again, chapter 2 is lit review, so it's all you guys. And then chapter 3, when you have methods, it can help you identify and compile your survey or questionnaire, and again, to work with your analytic approach and software. For chapter 4, which is the findings chapter, if you need to do any data cleaning and wrangling, welcome to the correct workshop. And also when you want to learn about presenting your results or data visualization, hi. And then chapter 5, the discussion, conclusion, implication, future research, you work on that on your own with your faculty. And then lastly, in the post-research, when you come to presenting and publishing your study and you need help creating the correct data visualization for your manuscript or your dissertation, again, howdy. Okay, so these are my areas of expertise. I do quantitative and qualitative analysis, geospatial data, and analysis, of course, surveys and questionnaires, data cleanup, visualization, and then help you with publication and presentation. So now come to question, what do you not do? I don't do methodology. I don't help you with your writing, and I don't help you with research data management. You have other resources here on campus. Methodology should be between you and your faculty that you're working with. And if you are the faculty, then you should know. Writing, you have the Writing Center to help you out and run some ideas and work on your writing skills. And research data management, we actually have a whole department here at the library, so please contact them directly. These are the workshops that we offer. So a couple of weeks ago, and I see some familiar faces, so thanks for coming back, we had using Qualtrics for survey data collection. The recording for that workshop is in the LibGuide, so you're all welcome to review that. Today we are doing cleaning data with Excel and OpenRefine. In 2 days, so on Thursday, we're going to do a quantitative analysis guide, which statistical software to use, where we're going to review R versus SPSS. In a couple of weeks, we'll do text analysis with Voyant and introduction to Tableau. And in early November, we're going to learn about visualizing data and storytelling with maps. If you do need to contact me, you're welcome to email me directly to hila.singh@unlv.edu or via the scheduling widget. You can go from the main library page and you go to the Meet with a Librarian link, lead technology consultation, and here I am. Now that we are ready to start with our actual workshop, I wanted to acknowledge John Little from Duke University Libraries, who actually created this amazing workshop and compiled all everything that was that you will see soon. And he licensed it via Creative Commons, so anyone can use it and repurpose it as long as it's for non-commercial purposes. So today, the learning objectives are to learn how to prepare messy data for analysis and to identify different functions within OpenRefine to clean data. We're going to learn a little bit about why cleaning data, and then we'll do some hands-on practice after I'll show you a quick demonstration. So why do you want to clean data? So as you will work on your research, and for those of you here may already know, that the proportion of tasks in all data project is that most of it, and by most of it I mean like seriously 80%, is cleaning your data. And only just a really tiny factor of it is analysis and visualization. And data cleaning before OpenRefine was super tedious and a lot of times really confusing as well. But why do you need even to clean data? So cleaning data is a necessary step. It's a necessary step because sometimes the data that you get is inconsistent and it's not going to work well for you, so you need to clean it up. Another phrase is garbage in, garbage out. So if you have garbage data coming in, trust me, you will have a garbage of a manuscript as well. And then the nature of data is that information is naturally unstructured, and analysis tools prefer precise data structure. So for example, one of the first gigs that I had as a graduate assistant was to clean data that we gathered for about 10,000 participants in an online survey. And the first question, well, one of the first questions that was asked was, what is your height? And lucky me, it was an open field. So people were able to do like 5.8 or 5 foot 8 inches. Some of them wrote it in centimeters, and I had to go and figure how to clean all of that up. And trust me, it was a pain. So 2 things I learned from that: A, open fields are a no-no, and B, this is how you really need to clean why it's so important to clean your data. OpenRefine. So now that we do have OpenRefine, it will make it much more easier and could even be interesting, no promises, but definitely easier. So the menus are much easier to work with. You can clean inconsistencies using really powerful clustering and editing algorithms, and we will go through all of that. You can transform data by using Growl, which is a regular expression language that is used on OpenRefine. Why do you want to use OpenRefine? For example, if you don't want to be a data engineer, but you need to fix your data, there it is. You don't have to deal with file handling. You don't have to write complex conditional statements, which a lot of time happens in Excel. And you don't have to think hard about how to manipulate stuff. And honestly, sometimes OpenRefine is simplest to use than Excel for data transformation. But for those of you who use Excel already and are comfortable with that, I'm going to leave that decision to you. This is how we start with OpenRefine. It is a free software. It is actually already existing on your computers, and we're going to test it out in just a minute to make sure you actually have it. So it works with Google Chrome or Mozilla Firefox. It will not work with Internet Explorer or Edge. And all you have to do is click on this OpenRefine shortcut in order to open it, and which will open a CMD, like a command window, which you can minimize, but it has to be open all the time. So does everybody have an OpenRefine icon like this on their desktop? Does anybody not have that? Cool. You don't have to open it just yet. I will do a quick demonstration about what OpenRefine looks like, and then we will work on stuff together. And as we work along, I want you to know that I know there's a lot of information that's going to be here, so I'm going to repeat everything at least twice. Once I will demonstrate it, and then the second time we will work on it together. So you guys really don't have to worry about that. Another thing you should know about OpenRefine is that whereas it is working in a browser, internet connection is not necessary. It is kept in the memory, in the local memory of your browser. So, for example, if you are working on a lab computer and you brought in your data, you want to make sure that at the end of your session, you export it as a CSV or an Excel file or anything like that, that you can actually take it with you, just in case you don't come back to the same computer, or if somebody cleans like the memory of that web browser between sessions, just so that you won't lose everything that you've done already. Function we will cover: importing data, faceting and clustering, which I'll show you what it is very soon, splitting and concatenating, search and replace, and if we have enough time, we'll also do a little bit of web scraping. There is a libguide that accompanies this workshop. It is guides.library.unlv.edu/openrefined_GWS. The link for it is also going to be on the board because I know some people don't type as quickly, so it's no big deal. And let's get started with OpenRefine. So I'm going to open OpenRefine, and I'm going to show a little quick demonstration, and then we will do a practice together. So as you open OpenRefine, like I said, it opens this command file, command window. So this is what it looks like. So I'm going to bring in a URL of a data. So I just copy and paste what the data is. So I will go to web address and paste it, and then I will do next. So it's downloading the data, and it is telling me what to do with it. So the first thing I'm going to do is I'm going to uncheck that quotation marks are enclosed. So I'm going to uncheck that, and I'm going to give it a different name. So first of all, you can see that you do have a little bit of a preview of what your data will look like as you're coming in. And then you can name your project and give it whatever tags you want. But I'm just going to give it a new name. And then we are going to create the project. So it's thinking a little bit. First, let's talk about the difference between rows and records. So this is row. And what row means is that every item has its own entry and that there are no things that have overlapping data. Whereas records have, I know the number didn't change here, but sometimes it does change. And an example of a database where it might change. So for example, if you have a record of countries that speak different languages, like speak certain languages. So for example, you have a record for every country. So let's take, for example, like, so you have like, Jordan and Lebanon and Saudi Arabia. So each one of them will be a row. And each one of them speaks Arabic as at least one of its languages. But if you were to have a record that's based on the language, you will have one record with those 3 countries. So the record will be based on the language because that is the common data between them. So then the record will be based on the language itself, and you will have 3 separate records. I'm sorry, 3. It will look like it's rows, but it actually records. And you can see, so if you were to do it by record, you can see that each one of those has a different color. So you can identify the difference between them. And I think in one of our activities, we actually have a way to take a look at that. So, so we have records. You can decide how many you want to show at a time, between 5 and 50. And then you can actually navigate your data by going to next, last, and so forth. So let's talk about facets. So a facet is a way to actually look at the information that you have in a certain column and how it might be brought together. So I'm going to find categories. So categories is right here. Okay, so categories. And I'm going to facet, and I'm going to facet it by text because it is a text column. So you can see here all the different categories that go inside this single column. And you can see that it might be kind of confusing. So you have 31 choices right here. So what we have is kind of like a mashup of pipe delimited. So you can see those vertical lines between some of these categories is pipe. And sometimes pipe is a character that's being used, depends on what data you have, in order to be able to separate data into columns. But what happened here is that it wasn't identified as a separator, so it just combined everything into this one column. So we have these 31 choice categories, and we can look by the name, or we can try to look at them by count, so we can see what are the most common ones, and it goes down to show what are the least common ones. So we're going to look at it by name. So I just wanted to show you, just so that you know, and I will never forget that I actually showed it to you, how to export it to CSV. Super simple. Just go to export on the top right. And you can export it as tab separate or comma separate value, which is a CSV. When I open it, it will just be like a very normal CSV that you can open with any data manipulation program. Another thing that we can do here, and we look at facets, we can decide to focus on different facets. Oh, and another thing that's kind of cool, and you'll see that as we will progress through, you will have the entire history of undo and redo. So if you ever did something and you're not sure what happened, you can go to undo and redo and just go back in history to show you that. So facet filters, we are going to separate categories We're going to edit cells and split multi-value. So now we are going to separate them by that pipe, that character I told you. So now, as you can tell, we have 180 rows, but we still only have 72 records. So as you can tell, so again, record is one. For every record ID, we have the entire length of data. And for rows, each one of them has just slightly different information based on what is the joined, like what is the thing that is in common and what is the thing that we separated. So for example, for rows, we have like this one record and a category is bicycle and its next category is transport land. If we put them together as a record, bicycle and transport land. So because it's in gray, you can tell it's all part of that same record. Another thing that we can do with facets is to limit. So we are going to category again and open the facets and text facets. And we can, for example, limit it only to juvenilia, and now we only have 4 records that we see. So 1, 2, 3, and 4, and that's it. Which means that if you have a certain category you want to work on, you can just limit only the view to that, just work on that, and then go back to the rest of your data. Next thing that I want to show you is how to web scrape and do API. And when I talk about web scrape, meaning that I am connecting my data with data that is available via an API online, so data that's available via some website, so that I can bring that data in. I bring it as a JSON file, and then I will parse the data so I can extract exactly what I need. These are things that are good, for example, if you are comparing your data with some government data, whether it's like, crime statistics, or if you want to have stuff like census tract data or demographic that you will download from the census. That's a really good use for this program. So let's look at new link. And I am going to add column by fetching URL. I'm going to rename it to web data. And the throttle delay is by millisecond, which is 1/1000th of a second, so which means that for now, every record will take 5 seconds to go to the website, browse around to figure out the data, and come back. You usually don't want to have it less than 2 seconds, so 2000 milliseconds, because then a lot of times websites will kick you out because they'll be like, oh, it's a robot roaming around my records, and they don't like that. Okay. So that is fine. So now it shows how it's bringing some data. And let's press OK and see what's happening. And this might take a while depending on how large your data is. So we're just going to stand here and wait. Yes, sir?
How many websites is it looking at right now?
So the question was how many websites you're looking at right now. It is just looking on this one that is told to go to. So later, if we actually have time to do our own web scraping, we will connect to a separate website, and we will tell it, based on this categorical information, I want you to look through your API and bring back information to me. So, and then I will specify exactly which data to go to. So each time it goes to the one website you specified to where to go. Yes. Any other questions while we're waiting for this to happen? Um, you know, I think it depends on the data and it depends on the website. So, for example, there are things that are really, really easy to do. Like if you have, for example, an address and you need census data, so easy. You just go to the census API, you put in whatever information you need, and it just, you know, spits it out at you. And it is the easiest thing. As a person that does GIS all the time, like that really has saved me a lot. As for SQL, I think that you might be able to customize it better. So like I said, it kind of depends on the website and your data. You know, I think one of the interesting things with OpenRefine is because you can really minimize your data to like just a couple of categories, you can test it out first with just like a short amount of time. And see if you get the information that you want. But sometimes if you have, you know, thousands or tens of thousands of records, which is totally normal these days, it might take you a while to run through because, again, it has to have at least 2 seconds for each record. So, yeah. Cool. So we got this web data that looks pretty extreme. So what we're going to do next is we're going to parse this data, which means that we're going to like a big, like, you know, block of this like gobbly text. And it is in HTML because we just went to the website and just dropped it as HTML. But you can tell it how to bring it back. You can bring it out as JSON, which we might do later. And then you use Growl, which is the Google Refine something language, to parse data, to isolate it to specific bits of the desired information. So we will come back to that option, but let me just show you what it looks like right now. So I'm going to edit the column, and add column based on this column. And don't be too traumatized by this language, but this code right here. If you ever need to find anything, I swear you Google it, and like there's like a huge community for OpenRefine that they can help you identify whatever it is that you need. Okay, so now, first of all, it's telling me no syntax error, and then it shows me a little example that will actually tell me what that is. So we'll do okay, and hope it's not going to take a million years right now. Yay! So now we have the web page title. So that is the data that it extracted for this big gobbledygook of text. And I will scroll down to the next record. And it got this frog bicycle light by Knog. So it does work. Okay, next thing that we're going to do, I'm going to show you splitting, concatenating, and then some find and replace, and then we'll go to the hands-on experience. So. Okay, so the first thing I want to do, because that takes a lot of space, I'm actually going to view, and I'm going to collapse this column. So you see it's still here, but it doesn't take as much space from my screen. So I'm going to go to production date, edit column, and I'm going to split into several columns. And my separator is just going to be dash or space dash space. And even though you don't see it, it knows the spaces are there because I wanted to split. I don't know if you can actually see it, but it was 1910 space dash space 1940. So I want to create something that just has beginning date and end date. So, okay. And now I have production date and then the second production date. And now I have these 2 separate columns. If I would want to concatenate, who knows what that means? It's a really annoying word. I say it in writing all the time. It's a very annoying thing to say. Essentially what it is that you take one column and you combine it, not add, combine it with a different column. Really, that's it. I don't know why they can't just say like add or find like a softer word for it, because I feel like concatenate sounds like a disease name, but you know, whatever. Okay, so let's look at height. And I'm going to add a column based on this column, because what I want to do here is to create a column that is height and width at the same time. So I'm going to call it, so again, I have this value and I'm going to call it height and width. So I'm going to call it value. And the way it's important to call it value, because we're taking the value from the current column. We're going to add the text x, so that's, you know, something times something else. And then plus cells from the column width dot value. Cool. So first, you can see in the example, you can tell there's no syntax error. We have this example to show us the preview, what it's going to look like. We're going to press OK. And even though this specific record doesn't have it, we can go to the next couple of ones, and we see 480 times 340 millimeters. Now, I'm just going to show you find and replace really quickly. Mention, edit cells, and transform. And what I want to do here is just to replace, so it's value.replace. And parentheses, I want it to take the for the millimeters, and I wanted to replace it with nothing. So between these two double quotes, I'm actually putting nothing in between. And we will press OK. And now you can see that there is nothing in between. And when I'll go to one that actually has numbers, you can see it's just 480 times 340. And that's it. So that is the end of my demonstration. So what we're going to do next is I'm going to invite you to open OpenRefine. So again, all you have to do is click on the diamond icon on your desktop, which will open this super cool command line. You don't have to leave it open, but don't X out of that. That's your connection to the world, to the OpenRefine world, but you can minimize it. And then it should open on Google Chrome or Mozilla. And another thing that you should have open is the guides, because the guides have the links to all of the text. So just make sure you open it. It's guides.library.unlvd.edu/opref_GWS. And I'll actually open it right here again so you can actually see it. And just let me know when you guys are ready. Just like raise your hand and let me know you're good to go. Everybody good? Awesome. Okay, so let's get started. Does everybody also have the library guide open on like a tab? Don't close it. We'll use it throughout the session. Okay. Cool. So in the libguide, go to, I'll make it bigger, go to Workshop Materials. And in the introductory exercise, we have exercise number 1, where we're going to look at Rally building permit data. So go to OpenRefine, go to Create Project by web address, and copy and paste this link. So I'm going to show you how to do that. So this is probably your landing page. So go to web addresses, paste the link, and press next. So you have this lovely data, but it looks like a little bit of a mess. Make sure that your columns are separated by commas. So right here on the bottom, press commas CSV, and now it looks so much better and more organized, right? Okay, let's give it a name, like Raleigh Building Permits. And once your screen looks like this and you're good to go, just press Create Project. We have, as we can see on top, 21,982 rows. Now this is real data. This is real data that was extracted from the building permit site for Raleigh, North Carolina. So this is legit. You might see something like that as you are doing your own work. So a lot of time you might extract data from a government entity and you look at it and you're like, oh my God, this is so messy. And now you know how to fix it. So we have 21,982 rows. And what I want you to do is go all the way to the right and find the work, well, not all the way, but just a little bit, and find the authorized work column. And we are just going to facet it just to take a look at what's happening. So you can see in this file, so again, we have 21,982 rows, but we have 7,633 choices. So now let's change, if from name, we're going to change to count. So just click on the count link, and it might take it a second to figure out what's happening. Again, there's a lot here, so, okay. So what is the fourth most popular type of authorized work? Yay! And how many permits are recorded for that? Good job. Cool. So we are going to try to cluster things now. And what cluster does is that it identifies words that should be the same but are spelled slightly differently. Now this is super cool. For example, if you have something like people spelling University of Nevada, Las Vegas. So you have University of Nevada, comma, Las Vegas, University of Nevada, space, Las Vegas, University of Nevada, dash, Las Vegas. So it identifies all these options and kind of takes a look. So we're going to press cluster. And it identifies that based on some algorithm that Google invented, and we're going to say thank you for that. So what we see here is that it identified that there are, for example, in the top row, in the top count, it has 4 options with 6 different rows, and it looks like they should be the same. So again, bath and kitchen remodel, kitchen and bath remodel, remodel bath and kitchen, remodel kitchen and bath. All of those are probably the same one. So, and even if you scroll down, you can see that essentially what it found is probably the same. So even if we'll scroll down a little bit, Samuel Cole Salon, semicolon, colon. So what we'll just do right now is we are going to select all, which is on the bottom left. So it just checked all of our options. And we are then going to go in the bottom. There's this bolded button for merge selected and recluster to merge all the terms. And we're just going to accept the defaults and let it think. And we can close that. So it did fix a little bit. So let's look, how many screen porch facets now exist? Okay, so it fixed a little bit. So now we have some more things that are combined. Okay, so let's click the deck facet. It's the third from the top, the one with 340 options, 340 entries. So now it reduced the amount of rows that it's going to work on to 340, because that's all that we wanted it to do. And now what we're going to do is we are going to combine the screen porch facet with the deck facet. So the way that you do that is that you hover your mouse over the facets for screen porch and click include. So just hover and click include. So now we have 574 matching rows. So now they are combined together. Okay, let's play around a little more. So let's go to the column land use code. So we might have to go a little bit to the right. Land use code. And we are going to get the text facet again. So facet, so the upside down triangle facet and text facet. And as it's loading, once it's ready, we're just going to limit it just to single family. So it's kind of like third from the bottom, depends on the size of your screen. So just click on single family. So now we have 519 rows. And now I will go to the right and I am going to facet that as well. And I'm only going to select the county of Durham, which just shows as DURH. So now we can see that in the county of Durham, in single family homes, we have only 3 entries for authorized work, and they are for both deck and screen porch. So it was just like a really like super filter that worked on multiple columns at once. Okay, so for this part, we are going to do mass editing. So the reason why we're going to do that is because OpenRefine was designed to transform data in bulk. So you can so it is possible to edit single data cells, but it's not convenient to do some other more what you see is what you get tools. So in this exercise, you learn how to accomplish like a mass transformation. So we are going to look at work type description. Work type description. And again, do a text facet, so facet, text facet. And if you'll scroll down, you see that there are new building and new building. And for some reason, it didn't catch that in the previous faceting that we did. Okay, so what we're going to do is we are going to select the all caps new building, the one with just the 3 records. And we are going to hover our mouse to show this edit, to expose this edit option. So again, new building, and it just, if you hover over it, just do the edit. And now you can actually type in new building with the spelling and the capitalization of the one above it. So capital N new space capital B building. And when it looks like this, you press apply. And now you can see that it was added to the other new building. And now we'll do the same thing for the other and other. So you can do it on your own. I'm just showing it on the screen, but if you have questions, please raise your hand, let me know. Let's split data in cells. So let's go to address, and we'll go to edit column, and we're going to separate that, split that into several columns. So again, let me show you. We went to address, edit column, split into several columns. Now what we want to separate here is that we have an address that looks like a very normal address, and then we have the longitude and latitude of it, the XY coordinates for it, and we want to separate those to two different fields. So the separator that we're going to choose here, so by separator, we're going to have open parentheses, so left parentheses, the one over the digit 9 on your keyboard. And once you have that, you press OK. So you see it already split that to address 1 and address 2. Then we are going to take address 2 and split that into two options. So edit column, split into several columns. And we're just going to keep this as the comma because that's all that it is. Excuse me. And now we have address 2 because it just automatically names it. And now we're going to change the names for it. So address 2.1 is latitude, so it's address, edit column, and rename this column. And it is just latitude. And for address 2.2 is longitude. So again, address, edit column, rename this column longitude. Okay, next we will do is we're going to concatenate cells together. Again, concatenating is just like adding them together to show the combination of what the values of the columns are. So let's go to square feet, which is right here. And we're going to edit column and add column based on this column. So edit column, add column based on this column. And the new column name is full description. And the expression is value, because we're telling it again to take the value from here, space plus space, cells from the column that is open with just a regular bracket, and then in double quote, proposed underscore work. And I will leave it on the screen for a little bit in case you guys trail back, and then close the quote in the brackets and dot value. And once you have that, you can press OK. I'm just going to leave it here so that everyone can type and know what's happening. Does it make it bigger? It does make it bigger. OK, so I'm going to press OK now. Is that fine with everybody? It created this combined column, and the reason there was a little bit of a mess up on my part, I forgot a space, but let's not worry about this now. We can add it another time. What it was supposed to look like is I'm just going to redo that one just to show you because I made a little boo-boo. So add column. Okay, so now we're going to head back to the latitude and longitude in order to fix them and kind of show what how we can do that. So the first thing that we're going to do is that we're going to latitude, and we are going to convert the data type. So let's go to latitude, edit cell, and we are going to call it common transformation, and we are going to transform it to text. And that's just all that we're going to do now. And then we're going to remove white spaces, because sometimes when you get something, you have like extra spaces before and after, and you want to remove that because then your data analysis software might see that as a different category or a different entry. So we're going to fix that. So again, so we're going to go to longitude. We are going to edit cells, common transformation, and trim leading and trailing white spaces. So now you can see it just took that space, and now everything is kind of at the same, starting at the same point. And now we're going to search and replace so that we can take that closing bracket off and we can have like a real longitude. So open longitude, edit cells, and transform. And the expression, so it's a replace. So you know in Excel you do like an if then. So it's kind of like that here. So it's value dot replace. And then you open parentheses. And then you tell it what it needs to replace, which is the text. So remember, everything that's in text has to come with double quote. The text is open parentheses. And you want to replace it with nothing. So just 2 double quotes, one right after the other, and close parentheses. So I know it looks confusing because we're like removing a parentheses, so it kind of looks funny. So essentially we told it like replace. So we want you to replace this with that, which is essentially what it will look like here. So, okay. And now it actually looks like a latitude and longitude. So yes, I agree that sometimes it's much easier to do like just a Control F and tell it to find this and do it with nothing. But there are some things here that I hope showed you that it's much easier to do it here rather than go back and forth to Excel for something. So if you're already in here to do something a little more complex, might as well clean the whole thing out, right? Yeah, I'm not anti-Excel. I love Excel. I grew up on it. So, but this just has different options that are slightly easier for some users. Yeah, yes? So that depends on so your question is if when we are connecting via URL, if we're connecting to live data. Actually, if you will just look at the link that you copied, this one is actually a CSV. So you essentially connected to a normal downloaded CSV. So this one is not. However, if you are connecting to a live data, I believe it will update with the live data. So that might be a benefit too. Let's do some web scraping. Okay. So when we're going to do web scraping here, we are going to, first of all, we're going to select a subset because as you can see, we have almost 10,000 rows here, and that's a lot of data to try and work with. So we're going to take like a subset of the data, so we'll have a little less data, a little less entries so that we can work with it. So first of all, let's do a subset. So what we want to do in here in this exercise, we're going to gather the FIPS code, which is the code for either the census tract or the county. It's a geographical identification, like a federal geographical identification number. And then, so once we're going to get that from the government, we're going to get it through a JSON format, and then we'll parse the data so you can extract exactly what you needed. So first, let's facet the data. So let's go to issue date. And we are going to facet and custom text facets. And we just want to slice it. So we are going to slice it and we're just going to do it right now. I'll just show you slice and open parentheses 6, comma 10. No, really 6. Okay, comma 10. And close. So what we did here is that we took this and we have sliced it just took the year out of it. And let me show you actually how that works on the back side of it. If you will go here, it's called position value, but depends on what you're looking at. It can be called slightly differently. So what data sometimes looks like is you can count the character in the cell itself, and you start from 0. So if you look at the screen, but as you will see, and you can actually see that also in the libguide, that the opposite is true. So if we wanted, for example, to take the AM or PM, we will have the value slice, and we'll count from -1 to -3. So you can even start from the end of the column as well. So something fun to learn. Okay, so let's go here. Cool. So now we have a 2014. So on the left, please select the 2014 facet and just click on it. So now we have just under 1,500 matching rows. And then from authorized work, excuse me. We will take facet, text facet, and you might have to scroll down and go to 3 season room. That's weird. Okay, I don't know why it doesn't show up to me. Does it show up to you, 3 season rooms, when you look anywhere? Okay, so you know what? From authorized work, just select something that is like around that is around 10 entries. So for example, that 10 at South person. Let's do that. That is so weird, because I had it the other day when I looked for it. All right, so let's pick that top 10 at South person, just so that we have only like a smaller subset. So now we only have 10 rows, so now when we're going to do our web scraping, it's going to be significantly easier. Okay, so now we're doing the API. So the National Broadband Map has this API that returns a FIPS code if we give it a county name or even a partial county name, and that's kind of easy. So what we're going to do is we are going to go to county and edit column and add column based on, add column by fetching URL. So this is what we're looking for. So the new column name is going to be JSON data. And the delay is 2000, remember, just for 2 seconds. And then the expression, let me see, I want to make sure you guys have it. So this is the expression you want to copy and paste. And this entire expression, you want to make sure you also have the single quotes, okay? So just copy it from the libguide. So just to give you a little brief overview of what you've seen, what you're seeing here is, so first of all, you have, so you're starting with an open quote because you're trying to tell it what to do. You're telling it to go to this website, and in this website, you want to look for this value, so that plus value plus is the value that it's going to extract from our database. And then you want it to come back as a format JSON. And now you see that it already brings up something and there's no syntax error, so good. So let's press OK. And as you see, when it comes out, it looks like another little bit of a messy data because it just comes back as a JSON language. Does anybody here does JSON? Okay, no worries. Let me show you how that looks. So now we're going to parse the data so we can extract exactly what we wanted. So go to this column, the JSON data that you created, and we're going to edit the column and add column based on this column. So the new column name is going to be called FIPS code. And the expression, did I provided you with that expression? Yes, it is also copy and paste this expression. And before you press OK, let me show you exactly what you're doing. Okay, so first of all, you see that the expression is working. So there's no syntax error. You have actual, like, something that looks like a legit FIPS code. And what it does, this is exactly what it looks like. So the JSON parsing, so if you were to create the JSON and just have it like open up, this is what it would look like. So what you're telling OpenRefine here is you need to take the value to parse JSON. This is the language that we're using here. You want it to identify the anything after the results section that will come automatically from this from this like phrase, from this JSON phrase. And then you want it to pick up county And after county, you want to pick up the code for FIPS. So everything is kind of connected here. So once you press OK, you can see that you have now the 5-digit FIPS code for this. So this is how you find stuff online and how you take them over, how to take it for yourself. Okay, so that was for that. Let's double check what else we have. So we still have 20 more minutes, so we can do the Growl. Oops, sorry, go ahead.
If you delete,
Well, first of all, you don't have to delete it. You can, by view, you can collapse it.
oh, okay.
But also, if you want to remove it, let's see. No, it's cool. Awesome. And even if you deleted something, go to the undo redo, and you can just go back to here. Do you see that? Awesome. Okay, so now let's do some Growl expressions, and so that we can learn how to edit a little bit more of it. Are you guys cool for that? Is that what you want to do right now? Okay, awesome. So we are going to open another piece of data. So go to workshop material and go to exercise number 2, and this is the data URL. So from here, just open a new one. Open URL and paste, and next. It already identifies that everything is by commas. And let's make sure we don't have to do anything else. Cool, and let's just call it police data. And create project. All right. Okay. Let's look at the location information so that we can identify. You have data that doesn't have like location information, so we can identify that. So let's go to location and facet, and then to facet by blank. So it's customize facet, facet by blank. Okay, so on the left we have the two facets. We have true, which means that it is blank, or we have false, that the cell has data. So if you don't want the location data, so you want to press true, and you will have 10,576 matching rows. In the next step, we're going to do what we did with the year in order to create the subset of the data for the Raleigh information. So we're just going to use that slicing data. So let's go to incident date and time. We're going to facet, custom text facet, and again, value.slice. I'm sorry, just value. Sorry, only value. Open brackets 6, 10, and close the brackets. And you can see that again, it shows you a year. And we can see that for 2005, we have 10,007 rows. So that's just one way to like move your data. Let's click on remove all so we can do something else. Okay. So now when we only want to keep something with location value, again, we're going to do the location and we are going to facet, customize facet, facet by blank. So we want to limit that to true. And now we're going to all, and we just want to remove all of them. So all we're going to do is go to all, edit rows, and remove all matching rows. So we are only left now with things that have location. And then you can X out of the location facet. So does everybody have 75,967 rows? We're all here? Okay. Let's do something to normalize it. And actually we're going to, let's see. I just want to do something we haven't really done before. Okay, so let's create a text filter to explore, for example, how many incidents have bicycle. So let's go to the LCR description and do text filter. And we are going to enter the word bicycle. So we see that 251 incidents included something around bicycle. And the next thing, we are going to create a facet based on that. So we are going to create a text facet. So facet, text facet. So now we have 6 different choices for it. And we can decide, you know, how much, what was like the value of the bicycle, and that's what they based it on. So we can tell, for example, between $50 and $100, there were 119 different incidents. So that's another way to explore your data. Let's see. Okay. So we just have a couple more exercises and then we are done. So let's do a cluster. So let's look for cluster variations in the felony column. So let's go to felony and do another text facet. And then, oops. And then let's edit the cell. So felony, edit cell, cluster, and edit. And let's, instead of the king function fingerprint, we're going to use this metaphone 3. And each one of them is just a different algorithm to identify that. And then in order to merge, you don't want to merge. You actually want like a new cell value. So change it to felony. And the other one is not felony, and just capitalize that. So not felony, just so that everything is together. And then you want to click. Oh, sorry. You want to do the check boxes, merge selected, and close. And now, oh crap, now we have this one. So let's fix that last one for not felony. And now it's actually all fixed together. Cool. And does anybody have any questions about this? Awesome. So if I could please have you go back to the LibGuide and go to the start here. And then if you could please go all the way to the bottom to do the workshop survey, so I will know how I did and what we've learned, so I can learn and improve. I would really appreciate that. And if you have any questions, you are totally welcome to email me or schedule an appointment. And I hope to see you guys on Thursday in the R versus SPSS workshop.